Now, let's try to tackle the first question, which is whether there's any phase change to the reflected ray. So to understand what is phase change, maybe I'll show these two videos side by side and we can do a little bit of comparison with it. So let's start with the first video. Let's have a look. So here you have a slinky spring, a very long spring connected to a loose end, just a string over here. And you can see that when we transmit a wave on the right, it will come back on the right hand side. Whereas if we transmit a wave on the left, it will come back on the left hand side. So in this case, we can say that this is similar to the case where there is no phase change. Okay, so if the wave incident onto this boundary over here, so this is the boundary between medium 1 and medium 2. If there's no phase change, what will happen is if it arrive at the crest, the reflected wave, which is this wave over here, the wave reflected, will also come up with a crest as well. Okay, of course, if the incident wave arrives at the trough, it also get reflected back at the trough as well. So there is no phase change. You are not flipping the wave in any sense. Just like what you see in this video over here. If you send a wave on the right hand side of the Slinky spring, it will come back on the right hand side as well. So there is no flipping to the left hand side. Okay, this is a situation where there is no phase change. In the idea that we're talking about right now, in which we have light wave coming incident on this boundary, when will we encounter a situation where there is no phase change? We'll encounter a situation where there is no phase change only when our light is traveling from a medium which has a higher index of refraction to another medium which has a lower index of refraction. If you travel from high index of refraction to low index of refraction, the reflected ray will not undergo any phase change. Okay, you can also talk about it in terms of the speed of the wave that is traveling. If you have a high index of refraction, that means the medium is very dense, right? If the medium is dense, then the light will travel slower in this medium over here. But let's say if you encounter this medium B has a smaller index of refraction. Smaller index of refraction means by it is less dense. So if it's less dense, then the light should be able to travel faster in this medium. Okay, so if the transmitted wave moves faster than incident wave, if you're going into a medium that you can travel faster, what happens is the reflected ray, the reflected wave, it will not undergo any phase change. If you go from slow to fast, the reflected ray will not undergo any phase change. So we talk about in different cases already. If you go from high index of refraction to low index refraction, no phase change. If you go from denser medium to less dense medium, there's no phase change. If you go from a slower traveling of light to a medium with faster traveling of light, you have no phase change. You can think about it in terms of index of refraction. You can think about it in the form of the density of the medium, or you can think about it in the form of the speed of the light traveling in those medium. Okay, so here I'm going to put in some mathematics into it. Material A is slow, material B is fast. How do we relate slow material to higher index of refraction? How do we relate faster traveling with lower index of refraction? How do you relate these two things together? So to understand it, maybe you need a little bit of equations to do it. So we know that NA is larger than NB over here, means by the index of refraction for medium A is larger than the index of refraction for medium B. So how does this correlate with the speed of the wave traveling in this medium? Well, we know that index of refraction, its definition, is the ratio of the speed of light to vacuum to the speed of light in that medium. Or you can say N is equals to, okay, let me write here, N is equals to the speed of light in vacuum divided by the speed of light in the material or in the medium itself. So right now you are able to change this NA over here to be C over VA, where VA is the speed of light in medium A, whereas VB over here is the speed of light in medium B. Now C is the speed of light in vacuum and it's a constant value, 3 times 10 to the power of 8. Okay, so we can cancel out the numerator that we have over here, then if you cross multiply to bring it upwards, you see that actually VA will be a smaller value, VB will be a larger value. So VB is larger means by it is faster at medium B, it is slower at medium A. So that's how we know high to low means you're traveling from slow traveling medium to a fast traveling medium. So you can think about it from slow to fast or from high to low, you have no phase change. Or you can think of it as denser medium to less dense medium. Okay, so this is for the diagram on the left or the video on the left. Let's look at the video on the right now. Okay, so video on the right, you still have the same slinky spring, but it's connected to a fixed point. That point cannot move. So now you see if I transmit my wave on the right, it reflect on the left. Transmit on the right, reflect on the left. Okay, so this is a new situation, a very different situation from just now. Just now, if you send your wave forward on the right hand side, you come back on the same right hand side because it was a loose end. Okay, but now because we fix it on a fixed end, if we send our wave on the right hand side, you come back on the left hand side. So essentially what happens is your wave is being flipped, your wave is being shifted. Okay, so what do we mean by shifted? It has being shifted by half a cycle. Okay, let's look at this diagram over here. So if the transmitted wave moves slower than the incident wave, means by the incident is fast, the transmitted is slow. Okay, or in other words, you go from low index of refraction to high index of refraction. What happens is if your incident arrive at the crest, what happens is the reflected will reflect off at the trough. So you see that it is not coming in as crest, coming out as crest, just like just now. Just now it's coming in as crest, it's coming out as crest. But right now it's coming in as crest, but it gets flipped, it's coming out as a trough. It's not exactly true to say it's being flipped. What happens is actually it's being shifted. It is being shifted by how much? It undergoes a half cycle phase shift. What is half cycle phase shift? Half a cycle of a wave. A wave is actually just sinusoidal, sine keep repeating itself, right? So you know that one cycle is one sinusoidal. Okay, one sine over here is one cycle. So if you go by half a cycle, that means you undergo a half a wavelength change. Okay, so if it initially was at the crest, this is one wavelength, right? Crest back to crest is one wavelength. If you undergo a half cycle phase change, you're only changing from crest to trough. That's why initially you are arriving at the medium, arriving at the boundary with a crest, but you're reflecting back with a trough. That's the idea over here. You have been shifted by half a cycle, you have been shifted by half a wavelength, or in terms of a phase, you are shifted by pi radian. Okay, so this pi radian shift, or this half a cycle shift, or this half a wavelength shift causes what comes as a crest to come out as a trough. What comes as a trough will be reflected back as the crest. Okay, so what makes the difference between whether there's phase change or there's no phase change is what type of medium are you going from to, which type of medium are you going? You're going from which medium to which medium. Okay, if you're going from high medium, high index of refraction medium to low index of refraction medium, there's no phase change. But if you're going from low index of refraction medium to high index of refraction medium, there is a half cycle phase shift. So again, low to high, there's a half cycle phase shift. Fast traveling medium to slow traveling medium, there is a phase shift. Or from less dense medium to denser medium, there is a phase shift. Okay, actually it sort of makes sense. We know that high index of refraction means by it's denser, right? So denser, there's a phase change. If you look over here, you are transmitting from a very easy to move spring to a very hard to move wall over here. So wall is very much denser compared to the string. The string is much lighter, much easier to move. So this is like going from less dense to dense. That's why there's a half cycle phase shift. You go on the right, you come back as a left. Okay, here you're going from a slinky spring, which is slightly heavier compared to the free end, which is a string over here. The free end is hanging on a string actually. So the string is lighter. So you're going from a heavier medium to a lighter medium, a denser medium to a less dense medium. So you go from denser medium to less dense medium, there is no phase shift. That's why it goes at the right, comes back at the right as well. Okay, so everything sort of makes sense. They sort of relate with each other. But if you would like to make a conclusion, this is the same diagram as before. If you want to make a conclusion, is there any phase change for reflected ray? Yes, but it depends on the situation. If your situation is you're going from a small index of refraction to a large index of refraction, consider incident is 1, the reflected the next medium is medium 2. If you go from medium 1, that is small index of refraction, to medium 2, that is larger index of refraction. You go from small to big, it is this case over here. Small to big, there's a half cycle phase shift. Okay, but today if you go from N1, which is larger, a denser medium, or a higher index of refraction medium, you go to medium 2, which is a smaller index of refraction, or it's less dense. If you go from denser to less dense, higher index to low index is similar to this case over here. Go from high to low. So in this case, there is no phase change, there is no phase shift or phase change that occur. Okay, again, I want to emphasize that half cycle phase shift over here, half cycle here actually means half a cycle of a wave. So one cycle of a wave, if you start from the crest, it's going back to the crest. Okay, so if you half it, then you flip it to the trough, which is actually half a wavelength away. So half a cycle actually means pi over 2 path difference. You have already shifted by not pi over 2, shifted by lambda over 2, sorry. You have already shifted your wave by lambda over 2, means by half a wavelength already shifted. That's why just now we say it's crest, right? If you shift by half a wavelength, it'll be a trough. That's why it's emitted or it's reflected at the trough. Okay, not pi, what do I repeat pi? Lambda over 2, half of wavelength of difference. If you arrive at the crest, you shift by half a wavelength, you become a trough. That's why you get reflected as a trough. Okay, if you think about in terms of phase, then it differs by pi radian, because you know one cycle is 2 pi radian, so half a cycle it's pi radian. Okay, so you can think of it as a pi over 2 path difference or a path change, or you can think of it as a pi radian phase difference or pi radian phase shift. Okay, so keyword low to high. Low to high, there is phase change. Low to high, there is phase change by pi radian. If it is high to low, there is no phase change. That's the main message that you should carry away from this video over here.